Welcome 7th grade. I'm trying this for time 4. No phone calls, hopefully this time. Pythagorean theorem. Very important. Used in construction, used in measuring for surveying, used in many areas. Very many applications. Now, square roots aren't always perfect. So like square root of 18. Well, I know there's a square root of 25 and a square root of 16. So 18 by 16, I'll say it's 4. This one's right by 25, so I'll say it's 5. 9 times 9 is 81, so it's 9. 11 times 11 is 121, so I'll estimate it's 11. We're going to use skills like that today. The Pythagorean theorem can help you find any length of any side of a right triangle. Only works for right triangles. Leg, hypotenuse, Pythagorean theorem. We will need to know these. Legs, they are the two sides that form the right angle. They will always be shorter than the hypotenuse, which is the side across from the right angle. We'll see a picture. These two work together to make a 90. That is the hypotenuse. It's important that is always C. This leg can be A, this leg can be B. Or let's switch it around. This leg can be B, and this leg can be A. The reason for that is we do something with adding, and because of the commutative property, we can add in any order. Now, this is the history. A Greek mathematician called Pythagoras came up with this, and that is why it's named the Pythagorean theorem. A squared plus B squared equals C squared. That you're going to need. The A and the B, you can see we're adding. So it doesn't matter which leg is A and which leg is B. But the hypotenuse, very important that it be C, because it's all by itself. If it's not, it'll mess things up. You can use the Pythagorean theorem to find the length of any side of a right triangle. Here, leg, hypotenuse. We want to use our A squared plus our B squared equals our C squared. Plug in the numbers. I could have 12 squared plus 16 squared equals C squared. Now there's something important you need to know. Square root of 81 is like the square root of 9 times 9. Oh, there's a pair. It's 9, since it's 9 times 9 that makes that. So the square root of C squared is kind of like saying the square root of C times C. It's C. That becomes very important, okay? We have to get it down to just C. We can't have C squared or A squared or B squared. That is an important piece of information. So, we do our math. PEMDA, we must do this first. 144 plus 256 equals C squared. We add these together, we get 400 C squared. Now, I want C all by itself. That's not all by itself, so square root of C squared is C. Do it to one side, we must also do it to the other side. 20. Our hypotenuse is 20. It's longer than either leg, so we know we have a good answer. Let's check their math. All right, they fill in the circumstances just like we did. They do the math without showing any work. All right, they get there. They take the square root. When we take the square root, we get our answer, and we were right. Good job, y'all. Now here, we still use the same formula. A squared plus a B squared equals the C squared. Problem is, I have A, I have B, I have C. I don't have B, but it's okay. I can have 5 squared plus B squared, I don't know what it is, equals 13 squared, because that's what C is. Okay? We must use PEMDA. Do the square roots first, or do the squares first. That's 169. That's B squared still. That's 25. Addition. Now we got to think back to our inverse operations. With inverse operations, oh yeah, I want the b by itself. I'm going to subtract 25. I'm going to subtract 25. 144. B squared equals that. Square root of b is b, or b squared is b. I do it to one side, must do it to the other side. B is 12. 12 is smaller than 13, which is the hypotenuse. All things in life are good for this problem. All right, so here we go. Let's see what they plugged in. Their neat and tidy handwriting. Hey, same stuff I was doing. We do the subtraction, that inverse operations, right? It's addition, so we subtract to get it away. B squared equals that. We take the square root of each side, and we get b equals 12, and happy, happy, we have the answer. All right, this time, we have a and b, we don't have c, so we can set it up as a squared plus b squared equals c squared, and I'm going to put 11 squared plus 15 squared equals the c squared. So my second step, 121 plus 225, I do believe, all right, equals c squared. I add those together and I get a 6 and a 4 and a 346 equals c squared. Now here's where, I don't know it. So I know I need to take the c squared, c equals, and it's between 18 and 19. I'm going to guess it's about 18.5, I think. That doesn't really make sense if we got that there. Maybe more like 18.6 because we have a 6 at the end, and I know 6 times 6 is 36. So 18.6 is our estimation. If you don't know these, you can make a guess like I did, but be educated and know, 18 squared, 19 squared, it's in between those. And about halfway, and then you see a 6 at the end. Or use a calculator. I don't care. Let's check their math. They put in stuff just like we did. They put in this, 346. We do the square root of each, and we get 18.6. Nice, nice, nice. All right. Now, we have these again. I see A, I see B, I see C. Might be good to identify these first. 3 squared plus b squared equals 5 squared. 25 equals b squared plus 9er. Minus the 9, b squared equals 16. Square root of 16, square root of 16, b equals 4. That is less than 5, and you'll hear construction workers talk about the 3, 4, 5 triangle, or any form of that. So if 5 goes to 10, then this 4 goes to 8. This 3 goes to 6. If 5 goes to 20, this 4 goes to 16. This 3 goes to 12. And any multiple of those sides where they're all multiplied by the same thing are triangles where it comes out very nicely and very easily. Any of you have parents that work in construction, or maybe that don't even work in construction, they'd be familiar with that. We do our math, taking square roots, bada bing, we got a good answer. Now, draw a picture, draw a picture, draw a picture. We have a square. That means 75 on every side. About how far is it from one corner of the field to the other corner of the field? I see a triangle. 75 squared plus 75 squared will equal c squared. I don't know what c is, but that's what they wanted to know, isn't it? So we make a plan, decide what's important, draw a picture. That's even part of their plan. All right. We write an equation. The two sides, and they were the legs, because we know on a square we have right ones, and that was 75, and that was 75. That's our hypotenuse. We put that in, use the calculator to do the math. It's this huge math. All right, add them together. All right, square root of that is 106, so it's about 106. All right, we can double check and go back. One thing that does make sense, 106 is much larger, is larger than either of the legs, so that is a good thing if it's the hypotenuse. Again, we have a rectangle. A rectangle can be drawn or divided into two. 33 by 100. A squared plus B squared equals C squared. I bet they do that. We figure out the pertinent information and we make a plan. Drawing a picture should be a big part of your plan. Draw it out there. Paper is cheap. So, this football field that's 100 by 33, well, as we look at it, we can figure out the legs, and we do that. We multiply them out by taking them times each other. We get our numbers. We add them together. We take them square root. We take square root. All right? And we get 105.34, which makes sense. It's a little bit longer than either of the legs. We look back to make sure that makes sense, and it does. Hopefully you can do the Pythagorean theorem. Have a good day, all.